Okay, I will share my screen and then I guess we are good to go. Okay, so last day we started with recursion. We talked about what's the flow of recursion and couple of more discussion how would be proceeding with it. Along with that, we did some questions. Okay, so we'll be doing some more today. So let me open up the ID. Okay, and what's the idea how to think in terms of recursion while solving a problem? That is what we need to develop, right? And why is that? So if you want to do some repetitive task in programming, so the first thing which we learned all is loops, right? So if you want to do any repetitive task, you want to print something or you want to add, let's say, lots of numbers or traverse through the array, the way was go through for loop, right? So looping, for loop, while loop, or let's say do while loop, any kind of iteration, right? Next comes the recursion, which may seems like it is going through like it is going in the same way as loop goes, but with some, so there are some differences and there's some specific purpose recursion solve. Okay, so that is why we will be learning that. Okay, and we'll see a couple of more things today, so that we have more clarity, so as we go on with the questions it will be more clear to us, right? So that's the idea. Okay, now, so we discussed couple of questions which we can have it now also. Anyways, so let's see the Fibonacci number which we did yesterday, and let's do some dry run for that. Okay, so that it becomes clear to us. Okay, so I'll be starting. Give me a minute. Okay, let's get back. Close this. Close this. Close this. Now here is what we saw last time. Okay, so let's say that in printing of Fibonacci series. So here is what Fibonacci series looks like. So if you just start with, let's see, you are starting with one, then so it's one and one. Okay, then we start with two, so then it becomes three, then five, then 8. Okay, then 13, then let's say 13 8, it would be 21 and so on, right? So this is what we follow. Now, what we did last day is we said that we will be printing or will be getting the Fibonacci series, okay, by the use of recursion. So you can easily do this. We can easily generate this series using for loop, right? We can just store two, so have two variables and start adding up the two numbers to generate the third number. Okay, so that was one thing. Now going with recursion, so what happens in recursion basically is, so recursion is mean like calling a function, like calling the same function or calling a function again and again. Okay, with some varied parameters and with a specified base case. Okay, that is called as recursion. So that is what mostly recursion is. Okay, so let's see the example. I will create a Fibonacci function. Okay, Fibonacci function. So let's say there is a function Fibonacci which will be printing all the numbers. Okay, and it accepts two arguments, the first and the second. Okay, first and the second, and its job is to print the Fibonacci numbers. Okay, so let's do this. Um, we will be creating a method. Okay, so we'll be creating a method. So let's say static void maybe. Okay, so we do not, so we just want to print something, right? So it's static void Fibonacci, and here will be our first argument. Okay, so this is how, uh, first argument. Okay, and here it will be the second argument. Okay, now if you remember, there was a base case of recursion. In case of for loop, we have a condition which terminates the for loop. Okay, here we have a base case which will terminate the calling. Okay, so not terminate, which will not make further recursive call. Okay, so which will stop making further recursive call. Okay, so let's see that we are interested in all the numbers. We are interested in like all the numbers which are less than 100. Okay, so which are less than 100. Okay, so here is what the condition goes. So the second number should not be, if it is greater than 100, we just return. Okay, we just return. What is this? We'll see. Okay, otherwise it goes something like this. So we'll say print ln maybe. Okay, and here we try to print the number. Okay, so print our number, and next goes the recursive call. Okay, so based on the last discussion we had, so what should I pass here, guys? What should be the parameter? Can anyone suggest what should be written here? Okay, so in Fibonacci number, we see that we are getting the new number. We get the new number by adding the two numbers which are before, right? Same for this 3, 2 plus 1, 3. Same for this 5, 3 plus 2, 5. Okay, then 8, then 13, and so on, right? So this is what it follows. Now the same thing, if I want to do here, what should I do? What's the parameter I have to pass? Okay, second and okay, first plus second. Okay, makes sense. So this is what we would be doing. Okay, let's test this. Let's test this one. And yes, here it goes. Let's hope we do not have any compilation error. Otherwise, we are good to go. Okay, so we can see that 1, 2, 3, 5, 8, 13, 21, 34. Okay, so we can just verify. So 314 and 213. And same for 55, 415 and 235. And this goes 89. So 538 and 459, right? So we cannot go further, right? So this is what a recursive program looks like, right? Just so what we have to take care is, what are the parameters we have to pass. First thing parameters. Okay, next number of calls which is needed. Okay, so number of recursive call which is needed. So in our case, we just need to make a single recursive call every time. Okay, and the first rule was what parameters we are to pass over here. So what are the parameters we need to pass over here? Similarly, the third thing which is required is the base case. So if these three things are clear with you, so you can write the recursive function. Okay, so this is the criteria. Now let's do a quick dry run. What happened exactly, and how does a function exactly run in case of recursion? So what happens exactly? Let's see that. So whenever you try to execute a function, whenever you try to execute a function, so there is something called as execution stat. So there is something called as execution stat. In this execution stat, two two type of functions are there. One, the function which is in pending state, or the function is in running state. Okay, what is so a function can be in pending state, a function can be in running state. So our code is something like this. So our code is something like this. Let's say if second number if second number is greater than 100, we just return, right? So no further calls. Give me a minute, guys. Okay, so in case of Fibonacci recursive function, so we have something like this. Okay, and there is no function call if we just return from here, right? Otherwise, what we do is we have a println. Okay, so system print, and we are just printing the second. Okay, and the last one is our call. Okay, so the Fibonacci call, the function call. Okay, with the second parameter and second plus first parameter, right? So this is what it is happening, and this is our function. So what happened basically? Let's see. So which is having first as a parameter and second as a parameter. The first call. So um, who makes so who is so who makes the first call? Who make the first call to Fibonacci function? Like who is making the first call? Guys, what is the first function to run when you run a program? Okay, so who is calling this function? Main function, right? Okay, so this line is executed, or this function is initiated or called by the main function, right? With the parameters 1 comma 1, right? So the main functions call this Fibonacci function with arguments 1 comma 1. Okay, so you receive the function. So there's a, okay, give me a minute. Okay, now this is your function call. Your function call comes over here with the argument 1 comma 1. Okay, you check for this condition. Okay, so if you check for this condition, if that is this is matching or not. So if this matches, you just return where. So where does a function return to whom? The function which has, yeah, okay, correct. So uh, you return to the calling function. In our case, you will be returning to the, so whenever this function returns, you will be returning finally to the main function, right? So this is where you return at the like end. Okay, so this is saying to return. Now this was the first function call, so you came over here and just printed one, right? So this line just printed one. So line number one, line number two, and line number three. So this function is one was in running state. Now this function came on third line. Okay, third line. So here it sees a next function call. Here is another function call which we have here. Okay. So here is another function call. Now my first function, the first Fibonacci call with arguments 1 comma 1, okay, will stay here in pending state, and there will be a second function call. There will be a second function call with change parameter. With changed parameter, the parameter changes are second plus first. Now the same will happen. The first line will execute, second will execute, third will execute. You'll be printing the second part, okay, and then this function also goes in pending state. Okay, these are in pending state. So they were running state and now they are pending state. So only two type of function remains in the execution stack. Those are either in pending state or in running state. Okay, there's a third call which is going, so it will be calling your Fibonacci function with this. Okay, so it will be, sorry, it will be this 2 and this 3. Similarly, the next call would be something like, let's say, 5, and no, not 5, this is 3 and 5, and so on, right? Okay, so this is how recursion proceed. So all these function go in pending state, and when a function goes in pending state, there is one more thing which is stored with the function. So what is stored in a function? Can anyone say, like, tell? Okay, so when your function goes in pending state, the part which has been executed, after which the compiler or the machine or whatever is running the program puts a pointer to the line which on which the function went in pending state. So if there is a function call, there is a pointer kept at this function, so that whenever you return from the previous call, you will return to the same line, right? So this is what it means to be like storing the pointer. So this is the job of, like, whatever is handling the process in our machine. So that is handled by this. Okay. Okay, so what happens? So let's say that we wanted to print numbers till 5. Okay, now this condition matches. Let's make it small. So let's say that it was 5 and this increased. Since second was 5, there is a return statement. Okay, there's a return statement. Now this will be returning to the called function. Okay, so where to return? The function which has called this function. Now whenever you return from a function, that function is in now stopped stage, and that will not remain in stack anymore. it will just get popped out of a stack with its local variables. The same happens with this one. This one will be get popped out once this is returned. This will also popped out when this is returned. This is also popped out once it is returned. And finally they reach to the main function, right? So this is what it is happening. This is how recursion functions. Now remember, I gave you guys a number which is 10 power 3 calls in a single function. Okay, so there can be only 10 power 3 maximum calls in a program, right? So this is the limit. Okay, so 10 power 3 to 10 power 4. Okay, between this you cannot pass this. Okay, now if you pass this, you get. So what is the error do we get for this one? Anyone remembers? We got that error last time. Okay, let's get that error back again. I will mark this return as. Let's see this. Okay, so it says that runtime error. Okay, so say count. Okay, so it's not giving the exact one. Okay, so you can see that this has passed. So why this is coming in minus, that is separate. That is a separate discussion which we'll discuss later. But yeah, so this is sick out. So you get a stack overflow error. Okay, so stack overflow error is what we get. Now, which is stack overflow? So this execution is stack overflow error. Okay, so this is how our recursion is working. Is this clear, everyone? The flow is clear. Okay, so let's see some more questions so that we get some clarity. Okay. Okay, so let's see this question. So this question says last index of number. Okay, last index of number, and it says given an array of length n and integer x, you need to find and return the last index. Okay, so it says an integer x, you need to find and return the last index of integer x present in the array. Return minus one if it is not present in the array. Okay, so last index means if x is present multiple times in the array. If a number is present multiple times in the array, return the index at which x comes last in the array. Okay, the last occurrence. You should start traversing the array from 0, not from n minus 1. Okay, so if you traverse from n minus 1, hey, like it would be the first index. So we have to traverse from this. So it has already mentioned in the question. It is saying do this recursively, indexing in the array start from 0. Okay, and here we have got one example, but we can have our own example and try. So this is the Fibonacci program. Let's create one more one. Okay, so the question is last occurrence last occurrence of a number. First occurrence will be like homework for you guys. You can just like do the first occurrence also. Okay, so let's see that there is a sequence of number. The number is 4, 6, 8, 7, 4, 9, 0, 2, 3, and 4. So this is what we have. Let's say that it again. Okay, let's say that this is the list we are having. Okay, the last occurrence of the number which we have to find. The last occurrence means we have to tell which last index is in the loop. Sorry, in the array we are having. Okay, so the key number here is 4. So we have to give the index last occurrence of 4, and we have to supply the index accordingly. So in this example, This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the ninth index, which is the last one which we have to return, right? So this is what we have to return in the index. Okay, so let's see now with the for loop. So okay, how can we do this with for loop, guys? Okay, okay, very correct. So we can just like starting from the front, we can start from the back, and whatever the first index we can return, right? Okay, but the question, the question has given a note, so we cannot just traverse from the array from backwards. Okay, and we have to do this recursively. Okay, so okay, very nice. So like I guess for loop one solution is easy one. Okay, so let's try recursion and let's put our brains in it. So I will name the function last occurrence. Okay, so let's decide what are the things we need to pass over here. So what are the arguments needed in order to traverse this array using recursion? So what are the arguments needed here? Let's see. Okay, so one is array and one is key. Okay, anything else to start or it's fine? Okay, let's start. Okay, thank you for the help. Like guys, I want just responses, right? So whatever it may be, right, wrong, so it doesn't matter because we are anyways going through DSA, so there can be chances. I would be not giving the optimized solution in a first go, so like mistakes will be there, right? Optimization will be there, and we'll clear the concepts accordingly. Okay, so let's get this one every number inside an array. Okay, so first one is this, and second is the key. Let's have the key variable also. So I will say key is equals to 4, and we have to find the last index. Starting from, so the traverses should start from the first one. Okay, the first index, right? Static, and we need to create a function. Okay, last occurrence. Why have written int, or do we need void? Okay, let's continue and see. So we'll be discussing what can be like what should be good here or bad here. Okay, so this is one thing. The next argument is what we need as a key. Yeah, this is how you accept an array in, as a parameter. Okay, okay, let's figure out something. What would be the base case, guys? Try to relate with loop first. Okay, so keep in mind the loop solution, for loop solution. What do you do to break the loop while traversing an array? So what we do to break a loop while traversing array? So what is done? So you just say array length. Okay, so here is one more improvement. um, Now we have to compare the current index, right? So we need a current index variable also. Guys, do you agree with me? Is this right? Right? Um, okay. So for setting up the base case, we need to have the current pointer, right? So that we can compare. Otherwise, we do not have any data to compare with the index. Is it clear, guys? Okay, what we are going to return, that is also something we need to discuss. So let's be it, and let's move further. First thing to figure out is the base case. Okay, the first two things we are moving on. So we have already figured out what would be the parameters. Okay, first step of recursion. Second step of recursion, figure out the base case, which we have partially did. And there comes the third thing, what is the logic and what. So like logic and the obviously logic we have to write anyways, either in loop or in recursion. The point is what should be the next recursive calls. Okay, so before that, we have to do whatever we have to do the comparison in loop or recursion. So we have to compare if the current index is equals key. Okay, we need to compare this, right? So we need to compare this. Okay, and mostly we'll be storing the answer over here. Okay, let's say that it is -1 at initially, and we have answer equals to um okay, answer is equals to index. Okay, makes sense. So this thing we'll be doing in for loop also, right? So how to get the index, just compare and store the index in a variable. Okay, so there is only one thing left. What will be the recursive call? Anyone wants to try? So what should be the recursive call here? We are traversing over the array. Very correct, very correct. So it would be just index plus one. That's it. See how easy it is to like move to recursion, right? So it's not very difficult to do figure out. So you'll say index plus one. Okay, and one last thing here, guys. So we will be returning our answer. Okay, so we'll be returning our answer every time. Every time we return our answer. So what to return basically? So we have to return here. Okay, we have to return the index. Okay, and how is that, and what will be here is okay, if our index cross the array length, the question says if you do not find, if it is not present, return a -1. It means that if you search and you just reach the end of the array, put a -1 and that's it. Now here comes the return part. A bit of thinking will be required. So, what we are doing exactly is we are storing the current index, which if the current element is equal to the key, and we are making the next call. And I want to return the maximum index. What should I write here, guys? Okay, so there is an assumption you have to make while you do a recursion. The assumption is whatever the next recursive call is going to give me is a correct answer. It is a correct answer, right? So this recursive call is going to give me a correct answer. This is an assumption. Okay, now I am moving to greater index in the array. I am moving further in the array. So if it is trying to return me, it is trying to return me a index, greater index, which is greater than my current index. Okay, so this is my current index and I'm getting a greater index from this array. I will compare my current index with the index I'm getting from further a recursive call, and based on that I would be returning this index. How many of you are getting the condition here? Okay. Guys, you do you remember mathematical induction? Mathematical induction, class 11th, chapter 4, mathematics. Okay, anyways, that's for just for CBSE board. I don't know for other boards. Okay, anyways, so there is something we need to assume. We have to make some assumption while we are solving, while writing recursive solution. Okay, let's figure it out. So let's come back here. Let's see what we are going to do exactly. What was the example? So the example is 4687. Okay, so it is 4687. So this is what it is happening in the flow. 490 23, 490 23. Okay, and last is 48. So last is this. Okay. Now our recursive call is saying if it array. Okay, so if the current index surpasses the length of the array, it will just throw a minus one. Okay, so return minus one. Okay, otherwise store the current index in a variable if it is equal, so whatever be the index. Okay, and get a next index from the next recursive call with index plus one parameter. Okay, so let's see, the function was array index. Okay, and the key. So we made a next recursive call, and we are getting one more variable, next index, and this is the current function call value. Finally, we are comparing if next is greater than the current index, return next, otherwise return current. So here it is what happening. So here is your array. The first index is 0. Okay, and the key is there, which you have to find. Let's say the 4 is there. Okay, and first index is 0. Now this is the base case which didn't satisfy at index 0. Then you stored a index. Okay, then you have your answer from the current function call. You store in the index variable because the first one is itself the answer, because it is matching 4. Okay, so it is 0. And and after this line then comes this line. Here is a recursive call, so you make a recursive call with index I. Okay, with index I. Here you neither match this, neither match this condition, because you are at 4, now you are at 6, so you don't match this condition also. Just move forward, and your index holds just minus 1 because you didn't get any. Okay, and this next recursive call, same comes over here. Again this is 8. Okay, so again index minus 1. Moving on, finally you reach at this point, let's say this recursive call over here. Okay, so finally you reached here with array index 9. Okay, that is probably 9, and you have your index. Okay, so you have your index as 9 you had here. Okay, then you make the call here, so it is 10. Okay, array 10. Okay, but again this is not matching. Okay, then you made a recursive call here, which is after the array at index 11, but index 11 does not exist, so you return a minus 1. Okay, you return a minus 1. So where this minus 1 is getting stored, guys, when you return? Which variable here is holding the value returned by the next function call? Correct. So next index is holding the value returned by the recursive call, the further recursive call. So you will get a minus one from here, from this one. It will, you will compare this. So it is also minus one, and the next is also minus one. So you'll return minus one. But when you come to 9 at here, you are getting a minus one in the next index, but your current is 9. So you will return the bigger one. Okay. So whatever is the bigger index, we are returning that. Okay. And when you return the function, it just gets popped out. So you are returning this 9 again, again, again. So you reached at index 2, which was this is minus 1. Again you'll pop it out, you will return 9. You'll come here, you will again pop it out because it's minus 1. You come here, it is 0. Again it is smaller. This pops out and main function receives 9 as the answer. Let's run this and check our solution. Okay, says in the okay, I did not messed up brackets. I know. Do we have any other thing? Yes, correct. Thank you for the catch. Give me a minute, guys. Okay, I guess someone joined, but anyways. So int last index is equals to print your last index. So print last index. Chalice. Okay, so it says error index out of bound exception. So where did we do the mistake? Let's check it out. So it is index minus one. Okay, okay. So okay, this will be this, right? So you cannot go on array length, right? Okay. So we are getting the value 9. Okay. Let's change the example a bit so that we verify this. Let's have one more 4 over here at the last index. I will run this part. Okay, and yep. Let's see what's the solution now. So it is coming 11. Okay, so let's see if the last index is 11. So it's 2 to 4 to 6 to 8 to 10 and okay, 12. So this is 11th one. So what we did, we stored the current index, then we made the recursive call so that we get the next answer, and whatever was the greater index we returned. Finally, in the main function, we are getting this. Is this clear, everyone? Okay. So yeah, yeah. Tell. Hmm. अच्छा ओके ओके ठीक है इसको देखते हैं सो गैस हमने क्या देखा अभी कि व्हेन द फंक्शन गोज फ्रॉम रनिंग टू पेंडिंग स्टेट बिफोर दिस फंक्शन कॉल व्हाट वी डिड वी आर स्टोरिंग व्हाट सो वी आर स्टोरिंग की करंट इंडेक्स e के बराबर है कि नहीं राइट दैट्स व्हाट वी आर स्टोरिंग सो लेट्स अज्यूम दैट वी आर एट दिस पॉइंट ठीक है पहले यहाँ पे होंगे देन विल रीच दिस पॉइंट so let's store this one so this is probably the ninth index okay ninth index then you made the next call and then you made the next call at 8 it didn't have any so it index would be so its index would be minus 1 because answer is minus 1 and this doesn't match at 8 Finally you reached this point. Now here you will be storing in the answer in your index, which is 11. Then again you make the next call because the base case isn't met. So guys, it will not stop, recursion will not stop at the last index, it will stop at the, so there will be one more call over here, right? If you see there is a base case for equality, okay, equality की check लगी हुई है, so it will be one more call, okay. Then it will say that the base case will say, hey, there's no further calls required, so it will be sending a -1, okay. So यहाँ पे the first value, the first thing you are going to receive in this next answer is -1, which will be from the base case. Base case is returning -1 to it. And then हमने क्या किया? We said whatever answers I am getting in next answer, I will compare my current one, which is indeed 11, and what is going to be returned from here? 11, right? And moving on, now this 11 will be returned to whom? Who has called the function? So who called the function? This 8 called the function. ठीक है, इस 8 ने function call की थी. Then you will come over here, you will be getting 8 as the next answer, okay, because this at this line only you made the function call. ठीक है, so this next answer will store not 8, sorry. So what will be stored here? I just got confused. So this is -1, okay, and you will be returned 11 here, okay. You'll be returned 11 at this point. Finally you come over here and you see that you are getting 11 and this is 9. So this is not -1, but 9 is indeed is smaller than 11. So if here is 11, whatever we are getting, and you are getting 9 here, anyways, whatever be the bigger value, that is going to be returned. And if you check the complete array, 11 is going to be returned every time now in the flow. Is it clear, guys? Okay. Yep. Yep. So see, like the three things we what I try to say, like, and why focusing on recursion so much, guys. Trust me. You see the topics over here. So let me give you a basic walkthrough why is important. You see the topics here. The name is, so recursion is start here. This is recursion. This is recursion. This is also recursion. This is recursion. This is recursion. This is again recursion. Linked list, stack, queues, everything, binary trees, full on full recursion. Nothing else. You will find nothing else apart from recursion. Hash map, any topic you choose, parity queue. Just open the question and see. Like if you try to see the solution, so you just see graphs. To these all are complete total recursion, just recursion, nothing else. So we'll try to like clear it as much as possible. So try to ask doubts. Okay, if you have doubts, don't like keep it to yourself. Please put it forward. Okay, so that we can do it. Now I will. So for practice, I can suggest whatever the questions you have tried with the for loop, try to convert it with the recursion. Okay, even you can try traversing the array with recursion. You can do that. You can do that. Okay. So this, what is this question? It is saying given two integers m n, calculate and return their multiplication using recursion. Okay, you can only use subtraction and addition for your calculation. No other operators are allowed. Okay, so what I did. Okay, yeah. Okay, so what is saying basically? So we have to return this. Okay, and multiplication using recursion. So how can we use multiplication using recursion with addition? Hmm. Okay. So this one is easy. Easy. Right. This is very easy. Okay. Here is a question for you guys. There is a single operation our computer know. Okay. Computer means computer, simple computer. So there is a single mathematical operation our computer knows to perform. What is that operation, guys? Anyone knows which mathematical operation our system knows? There's a single one. So computer knows only addition. Okay, so it just knows addition. It does not know subtraction, neither multiplication, neither division, modulus, nothing. Just the addition is known to our system. Okay, that is a bit of like at semiconductor level. So it just knows addition. Next, like rest of the things are figured out with help of addition itself, right? Multiplication, subtraction, division. Okay, so there are several algorithms you can search on. Okay. What else? So how can we solve this question, guys? Guys, this is very easy. So m cross n you have to do, right? Consider this as an array of length 5, which is holding all threes in it. You have to sum into the array, traverse the array. 3 plus 3 6 plus 3 9 plus 3 12 3 15. Traverse using recursion. That's it. Return your next answer by adding the last answer plus 3. Make sense? Uh, guys. Okay, this is very easy. Try to do with recursion. I will not do this. This is uh, to be practiced. Okay, very easy. Geometric sum again. Okay, so okay, sum of GP with a common ratio is given to us. So it's 2 power k. So given k, we have to do this. Hmm. Okay, we can do this, but mostly it's using the methods though. So um, okay, so you can just follow up this one also. This one is easy. So just having this math.power function. So if you are searching for a function which would put up a power, so this is the index, this is your power. You just put it, and whatever the index, whatever the number you find, you have to just add it using recursion. Okay. Okay, let's see a good question which we can discuss. Check palindrome. Check whether a given string is palindrome using recursion. Okay, this is interesting. We can try this one. It will be a more clarity to our concepts. Okay, I'll just reset this part. Okay, let's see this question. So we have to tell if this current string is sorry, not recursive. It's a palindrome or not. Okay, let's just store this one. Okay, so let not let sorry, not int also. It would be boolean. It's bool or boolean. Okay, so it's boolean. Boolean answer is equals to if it is palindrome or not. So there will be a palindrome function. I have to check if this string is palindrome or not using recursion. So what should be the idea, guys? Anyone wants to try? What should be the idea? Passing the first index and the last index. Okay, correct. So we can do this. Okay, so passing the first and this string also, right? Obviously. Okay, so str dot length, and length is here a function because it's not an array, it's an string. Okay, so let's see. Let's see. So we have solved one step of recursion, which is what should be the parameters, right? So we have passed one step. Let's see other two. Static. What will be our return type? Boolean, right? So static Boolean. Palindrome. Is the spelling correct? Palindrome. Yes, that's correct. Now we are accepting a string str. Next one is a variable, which is the start index, and next to the end index. Okay. So here is what we are having. Okay. And what else? So base case. What should be the base case here, guys? Stop index is less than st is equals to n. Okay. 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 So st less than equal to n. Now, so we return. Okay. So there are two things over here which we need to take care. If st is equals to en, this is a separate base case. What I should return here, guys? Which case st is equals to en? Correct. So it should be true, right? Because a single string is a palindrome string. A single character string. So this is a palindrome, right? A is a palindrome. B is a palindrome. A, it's a palindrome, right? Is it clear, guys? Why return true over here? Okay. And the next one comes over here. So if st is greater than en, we should be returning false. Okay. But can we improvise on this one? Hmm. Okay. Can we think of something else so that this condition doesn't even arise? Can we think of that? Okay. So what happens if we have two length string? Can we handle that? I guess yes. What we can do here is, guys. So there's no problem with this one. The only thing I am trying to do here is see that if the string length we are getting is of length 2, okay, of length 2, and if if str dot caret, so caret was the function, right? I hope you guys remember. So if str dot caret start index, okay, start index, and the if it is equals str dot char at the end index, just return true. Otherwise, a false will do the job. Return true. And similarly, instead of writing this, can we write something like this? Str dot length, okay, str dot length equals 1, and okay, and we just return true. Okay, it's the same thing, right? Now, if these two are the base cases, now we are at the position where we have to compare our string. So here comes the program logic. So this would be, you would do in the for loop also, right? So what you do, comparing the first character in the last character, right? So this is what we do. So start and str dot caret and okay. Now if this is true, if this is true, then only then only we are going to is next palindrome, okay? Or maybe we can have this one outside. So if this is true, if the current string, if the current string we have got is true, then only we'll make the next recursive call. Otherwise I can directly say return false, guys. Is it making sense, guys? Okay. I I can directly say return false if these two, if the current string I am having is not palindrome, so it doesn't make sense moving forward, right? So we can stop there, just like breaking from the for loop. So if you don't match the character, you just break, right? Otherwise, what to return from here? Do we return this one, or instead I can do this thing? Let's see. So what should be the next recursive call, guys? What should be there? Okay, okay, makes sense. So start index. Oh, okay, 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 okay. Here's one thing, guys. Sorry. So I should have been telling that, but looks like we need to do a couple of more changes here. Okay. So okay, the current index and zero will be the first one. Okay. So should we proceed with this one or should I change it? Okay. See this, guys. I will do the with this one also. Just let's have a look at this one. See this. I think we do not need that. And why is that? See, I'll explain it. Don't worry. So let's see. Okay. And finally, what I'm trying to do here is this. This correct substring, and I can say one plus cr dot length minus one. Okay, so will it be minus one? Yes, it will be minus one. So last index is excluded anyways, right? Okay, guess you are getting this logic. Okay, so what I'm trying to do here is see this. So this was our the first string we had to compare. Okay, so we reached here. The comparison is first index and the last index, right? Str length minus 1. So R and R was compared, and we entered inside this. Okay, none of this condition fulfilled, so we entered this condition which fulfills. Okay, and this first index and the last index was compared, which was equal. So we are making this next call which says substring from starting index 1. So index less than, so index 1 less than str length minus 1. Okay, so this length will be a call. Okay, a function call. This length will be a call. Now the string I'm trying to supply here is this. This is what I will be supplying. So taking out this character and taking out the last character. Now I'm asking recursion, I'm asking this palindrome function to give me the answer for the sorted string, like what the sorry the sorted string, and check if this is palindrome or not. Now again this runs 0 last index, again substring. So this time what I get is this, again the function call for this one, again the first character last character matches. And what is the recursive call here, guys? It's e, and e has a length 1. So I'll be returning true. This gets true, this returns true. Okay, this again returns a true, and it goes on. And I need to move this one also. Is the solution clear, or should I do a try run? Every time we are making the string sort and getting the answer for the sorter string. Okay, sure, let's do that. Now the first string which is passed over here in the function palindrome is this, right? The complete was passed over here. The race car was passed in the string. Okay, so it says string length 1, no. String length 2, no. String. So then third conditions, we do not need this variable though. I'll just cut this part out. Okay, then string comes over here. So it compares what is the string we are getting. So it's race car, right? This is what we are getting. Now at this point we are comparing this zero character. So character is zeroth index and the last index, which is equal. I enter in this from 20 seconds. I'm entering in this line, and there is a recursive call which I'm making to the same function, but with a sort string. This substring function will only send the substring to the next recursive call. Okay, so substring is starting from index 1. Index 1 is a over here. Okay, uh, let's come down a over here. Okay, till the last index less than 1. Okay, because this is exclusive index, this is inclusive, this is exclusive. I hope you guys know about the substring function. If not, like, you can just follow the documentation. Okay, so you will be supplying the string this for the next recursive call. Now you compared this character. Now it's time to compare the sorter string. Now we call this palindrome. This matches no, this matches no. Again, this has this one. Okay. Now if you check, if you see, again the substring logic runs because A and A matches first string, sorry, the first character and the last character. Again, you say index 1, last index minus 1. The next thing you get is CEC. Okay, this is passed over here. from this call, palindrome call. Now at this point, you again try to compare first character, last character. You say it's true, so you make this call. Again, you only will be sending the first and this one. Okay, so you just send E, and palindrome with a length 1 is always a palindrome. So you return true over here. Okay, so you return true. So true comes at this point. Now this E has returned true to CC. Now the CC will again return true. Again a return true. Whatever we are getting over here, you're just simply returning it. Either it is true or false. So again return a true. We're getting a true over here. So you again return a true. And this again tries to return from the first call. So you get a true over here also. Is this clear now? Yes. Line number 18 and 19. Yep, because it could be false. Thank you. And we have got a error over here. It's saying comma. Where is it? Yep, we do not have a comma. Let's have this. Okay, so is it correct now? It is. Let's see if we have any error. It says true. Let's see. Wrong one. Okay, let's include a D over here. Let's say is false. Okay, let's have a even length palindrome. Let's say is true. Okay, and any others? Let's try this one. This is also palindrome, right? Yep, it's a palindrome. And yep, you are getting true again. Okay. um yep, this is it. Okay, so I hope it's clear now. Okay, if not, like, you just so the logic is like the same. Okay, try to solve a smaller one, try to solve a smaller problem and make the next recursive call. What things to figure out? What are the parameters you have to send? What will be the recursive call? Okay, what will be the next recursive call? And what will be the base case? Okay, so only three things are needed: parameters, next recursive call, and the base case. That's it. Okay. Okay, so if you have any doubts you can go on, otherwise that's it. We'll just be taking up the attendance. Okay, this is not the one. So where is RC? So it's Fab. So guys, if you already have the link, please mark it. Otherwise, I'll just share. So today we have 7, right? So it's 7. 7. It's Saturday. So let's mark Saturday over here. Showing the link. So please mark your attendance, guys, and please do not miss it. Right. So last time there was a. So what I do usually is I remember your names. So I mark the main dashboard sheet like with your guys, like the numbers you guys were present. And since the attendance was not there, so like management was asking me why you have written a wrong number. Please don't do that. So don't miss your attendance. If you are having any trouble marking it, you can just ask. Okay. Otherwise, please do that. Okay, and okay, so we have more people. We were having more people in the beginning sessions, but I don't know like why there's a drop in attendance. Maybe so there can be some reasons regarding the class or maybe the schedule or whatever it can be, whatever the reasons can be. So please try to communicate, okay, so that we can pick a possible solution, right? Okay. Okay, guys. So practice it. Okay. If you have any doubt, reach. Otherwise, we'll having the class at the same time tomorrow. So let's meet you there. Thank you. Bye. हाय भाई, हेलो। हाय भाई, हेलो। हेलो। हाय भाई। क्या हो गया भाई? हम्म। 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 ठीक है। हम्म। 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 ओके। सो ऑथेंटिकेशन वाले राउट्स हैं लॉगिन एम्प्लॉय। अच्छा। ओके। ठीक है। हम्म। हम्म। यार ये कॉल बैक है। ओके। हम्म। यस यस, ये तो नहीं है। एक मिनट देखने दो मुझे। ओके। एक मिनट देख लेते हैं भाई। स्पोर्ट लोकल। नहीं, बॉडी पार्सर का जरूरत नहीं है। हम्म। हम्म। ओके, एक मिनट भाई, देख रहा भाई। तो है थोड़ा इंडिकेशन। समझा समझा। ओके, एक मिनट, देख रहे हैं ये कुछ और तो नहीं गलत किया ना हमने। ठीक है, ठीक है। ठीक है, मैं भी एक बार श्योर हो लेता हूँ। तो कुछ और तो मिस नहीं कर रहे हम लोग। सीरियलाइज डीसीरियलाइज तो हमने यूज़ कर लिया है। सीरियलाइज ईमेल के बेस पे कर रहे हैं, राइट? अच्छा अच्छा। यस यस यस। एम्प्लॉय डॉट फाइंड। भाई एम्प्लॉय डॉट फाइंड, ठीक है। हम्म। हम्म। अच्छा अच्छा। नीचे जाना, हाँ, एम्प्लॉय डॉट फाइंड और एम्प्लॉय। भाई एम्प्लॉय डॉट फाइंड एरे रिटर्न करता है ना? तो हम लोग रिटर्न, हाँ, जेसन में एरे होता है ना? वैलिड वैलिड है ना एरे? हाँ, एक से ज़्यादा डेटा एरे में ही आते हैं ना, एक से। एरे में एक ही एलिमेंट आएगा शायद। सही बात है, एक ही आएगा। हम्म। हाँ, एक बार फाइंड पे होवर करना। देखो तो क्या रिटर्न कर रहा है ये। गेट्स अ लिस्ट ऑफ डॉक्यूमेंट। भाई ये पूरा लिस्ट रिटर्न करेगा ना? अगर एक ही होगा तो लिस्ट में एक ही आइटम होगा, एक ही एम्प्लॉय होगा। तो वहाँ पे, हाँ, वहाँ पे ज़ीरो करके कर सकते हैं। यस यस, वो ट्राई करना। और यहाँ नीचे, नीचे भी ज़ीरो। ठीक है, वो उसको वो कर दो, हटा दो वहाँ से। हाँ, नीचे ही सही है। ठीक है, एक बार ट्राई करना। हाँ, ये एक बार ट्राई करना। हो गया? क्योंकि वो कॉल बैक के अंदर है ना, तो वो तो सिर्फ एक ही बार कंपाइल हो जाएगा। तो प्रिंट, हाँ वो कॉल बैक के अंदर है तो वो तो नहीं प्रिंट होगा। भाई ये हटा देना यहाँ से, वो हटा देना ऑब्जेक्ट पास रिक्वेस्ट टू कॉल बैक, वो हटा दो वहाँ से। यस यस। ईमेल पासवर्ड रोल, भाई रोल पास कुछ और पास कर सकते हैं क्या यहाँ पे? ये आर्गुमेंट पे भी डाउट लग रहा है। ठीक है, एक बार बिना रोल के ट्राई किया था क्या इसको? चला है? ट्राई कर लो एक बार बिना रोल का। किसी एक को ही ऑन कर दो, एम्प्लॉय को ही ऑन कर दो, बाकी वाले को बंद कर दो। इससे पहले कि इसमें लोकल लगाए थे क्या स्ट्रेटजी, ये वाली चीज़ लगाई थी किसी पहले प्रोजेक्ट में? अच्छा अच्छा, तब ठीक है। हम्म। हम्म। हम्म, अच्छा। समझ गया ब्रो। एक चीज़, इसको रेफर करो ठीक है, इसको एक बार ट्राई करो, इसमें कैसे किया हुआ है। एक मिनट देना। अ, 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 एक रेपो भेज रहे ठीक है, उसमें तीनों स्ट्रेटजी करी हुई है, वो मेरा ही प्रोजेक्ट है। उसको एक बार ट्राई करो, उससे करने का ईजीएस भी यूज़ करा है ना वो इसमें भाई। अच्छा अच्छा, ठीक है ठीक है। कहीं ना कहीं तो होगी।